just remembered I need to start recording. Okay, recording now. So we're in the make targets section, talking about adding in friends or foes and not getting things to populate in the safe zone. So we created this property called friend or foe. So just all we have to do is say targets array I, which is talking to the current element of that array. And this is by doing dot friend or foe and assigning it a value, it creates that as a property that's now available, which is cool. You know, you can just sort of, when you're creating characters or creating anything, you can give it properties that then you can then check and test later. And so you see I did 2 of them as friends. And then in this third case, which was a little bit more like the gray blocky guy, he's our foe. So that's the one you're supposed to avoid. Whereas the 2 friends are ones, if you collect them, it's good for you. So we can look at that in a little bit, but before we get further away, I want to look at the while loop that I was just talking about. So we've decided which image our target's going to use. Then we do the regular registration of it, reg x and y, like we did before. And then I do continue to make a first stab at where the location is using our regular random values. And so it's just within the whole stage, it makes a random guess about or a random choice about where the x and y is going to be. But then it goes in, this is just as the scaling, so how large it is. So then we've made this random choice about x and y, and then our while loop has a structure that looks very similar to like an if statement or a for loop, probably more like an if statement. So let me just draw one down here, because this is a pretty complex while loop in its conditions. But basically what we're saying is while some condition is true, and this is pseudocode, do what is in here. And this code is freaking out because this is all sorts of keywords and whatnot. But while, and then some condition is true, this is the thing that you're testing for. So long as that is true, it's going to keep doing whatever is in here. So it's important to remember this is what it's different than differentiates it from an if statement, because an if would just do the same condition check and then run it once and then keep moving on with itself. But this one is set up in a way to keep doing over and over again. So it does it and then it checks, is that condition still true? And it does it, is that condition still true? Et cetera, et cetera. So in here, what I'm checking is that the boundaries, and I made it sort of a 2-liner here. So it's a big condition that it's checking to see, is it in that safe zone? And if it is in the safe zone, choose a new random location. If it isn't in the safe zone, you're fine, and you can use that x and y as the x and y that you're going to work with and then move on. So I won't belabor talking through this part, but you can see that the first line is dealing with the x. So it's saying if the x is greater than the, what is it? Then the half of the stage width minus a safe zone, and x is greater and is less than the midpoint plus the safe zone. So that's like if it's in the middle of this. So in safe zone is just a variable that we defined up above to be like 100 pixels or 200 pixels, something like that. So we go to stage width divided by 2 is a way of getting the middle of the stage in x, right? And then I add some amount to it and I subtract some amount to it, and that's the range of on the x dimension. And then I do the same thing. Stage height is middle up and down, minus some safe zone and plus some safe zone gets us that sort of square in there. And so if this is true, it means that the target was populated somewhere in that safe zone. And if so, generate a new value. And so what I'm doing, you know, there would be other ways that you could approach this, where you're just in the generation, you make an even more complex statement that says like it has to be outside of those bounds when you're generating it. But for me, the brute force method of like generate a random number and check is it in the right place or not ended up being more efficient for me. And but like I said, you could make it work the other way as well. Does that make some sense about the basic idea there? And this safe zone idea could be moved anywhere. It doesn't have to be centrally located. You just have to reposition what your test conditions are going to be. Like if you wanted the top left corner to be exclusive for something like a starting point, you could define that as being that, and it would be easier if it's sort of adjacent to one of the border walls. And then the rest of it is all just the same as far as the make stuff there, or make the targets. The other thing maybe I'll just mention was so differentiating. Up here we had these which target, whether it's created a friend or foe. So let me just go down and show you where that is, where we differentiate adding to our score versus taking away our health. So we just separated those as down here in sort of boundaries collisions. We had a update score text, update health text. So I separated those things out. And then I also, so that just basically duplicated the update score text, but made it to be, so it's going to display the health somewhere. And then I moved all the like you win, you lose type of conditions, that kind of thing, into the check game over. And so here, if we look at that, we had to be testing if the score is equal to the max score and the game over is false, then we set it to be game over to be true and display you win. But then we had to extend the situation here so that if the score is not the max, you haven't reached the top score, and game over is false, and your health is less than or equal to 0, meaning you died, then game over is also true, and we say you lose. So that had to be just adding an additional conditional so that your health, if it goes down to 0, it does something. And I'm trying to think if there's anything else that we had to do that was really sort of unique about that. Let's see, somewhere we update, I think just when we had to update our, so if we go up and look at our collisions and what happens, that's where we're going to check stuff in here. So we have, here we go, we had collisions here for now 2 different classes. So if it collides with if the hero collides with a target in the array, first it checks, is it a foe? And if it's a foe, then you remove 1, you decrement the health by 1. Your health goes down by 1. And then also we made our character then bounce off of us, that the targets would bounce off of us. Because one of the things that we found quickly was that if we didn't do that, it would hit you, and then it would keep going through you, and every frame that it goes through you, it checks this, and there's a collision again, and a collision again, and a collision again. And what would happen is in 8 frames, which is like 1/10 of a second, you would go from like having full health down to no health, and you'd be dead. So we needed to have some way that the target still existed, because that's the way we wanted it to be in that case, but you'd only collide once. And there's a couple of different ways you could approach it. This was the easiest, and this was the way that the person that was asking this wanted it to happen also. But you could imagine some other situations as well. So you could have a target hits you, and then it bounces off, and so it hits you, takes off a health point, and then goes the other direction. You could also put things on where it would hit you, and the object could disappear. And then but it goes towards taking health off instead of adding to a score. So that would be another one that would have been fairly easy to implement. Or another one could have been that it could keep going, but you add a flag to it saying that you are, like, you collided once, don't collide again until collision's no longer true with it. And so once it passes through to the other side, you could say, okay, now it's safe to collide again. So that would be like another approach that's a little more complicated, but definitely doable. And then the last part of the collisions here is that we get, so if it's not a foe, well, in any case, it still comes back and checks in here and says, okay, now check if it's a friend. If it's a friend and then there was a collision, we add to the score and then remove it from the array and remove it from the stage. When we first did this, we actually had these things in a different order. We had this part happen first, but then you'd get into some weird errors, because if you got a friend and then it would remove it from the stage and remove it from the array, and then it would still go on and check, is there a foe at this address? And that address had just been erased. And so it might be checking the wrong target. It might be checking some target that's nowhere near you and deciding, oh, that's actually is a foe, even though it's not touching you, and it could cause buggy behavior. So we had to be careful about that. You could probably also clear that up maybe with a well, I guess the if then else might help as well, but in this case, just changing the order was sort of the cleanest solution on there.
So what would happen? That's interesting. So because you're saying if you go through the loop and you're counting down.
So I'll just paste it up so you can see it in this order.
Yeah.
So now if it comes in this way and it checks him as a friend,
yeah.
You remember it deletes the friend and adds your score.
So because you're splicing out. Okay, and then it.
Yep. So it takes it out of the array, and then it's going to check still position array I is still the same number, but since you've spliced it out, it's actually going to probably be the next one in the. It's going to be the next target that it's checking.
Wouldn't that just be an else statement? So you wouldn't check, right? You could just skip the check. If it's a friend, it's not going to be a foe, right?
Mm-hmm. Yeah.
So if you just said if, and then after on line 274, if you just put an else there.
There you go.
Yeah. Anyway. Yeah.
Yep. Great. Yeah, that's what I hadn't fully thought.
Right.
About. And I thought that if then else would do something, but
when you're on the fly doing it, right? Exactly.
Yeah. Changing the order also did it as well. So yeah. Cool. So let me.
That's something that we do all the time, because like the first time we write something, we get it to work, and then we can kind of look at it later and say, oh yeah, I could probably do this. That way it doesn't have to check it twice.
Yeah.
So yeah.
So there you go, like that.
Yeah.
So if there's a collision, if it was a friend, do this. Otherwise, you know that it was a foe. So do this. Yeah. Cool. That'd be a good other option there. Nice. So in any case, that's all here. So if you want to check that out, there's the damage demo here. And then is this, Miles, was this your updated the Sprite demo?
Yeah. Okay. We can go through that if you guys want.
Sure. Do you want to do that one?
Sure. Okay. Yeah, I just want to
sound stuff.
Cool. And then also just to kind of go back to what David was talking about, I think it's really interesting. And Rad was talking about this too, about diagramming stuff out, because I think someone who's really good with math and logic would just get this. But for me, I have to really draw it out so I can really think about it. And it takes me an inordinately long time to figure something out. So I was just thinking I think I've done this before, but slightly differently. But maybe it's basically the same. But I was thinking about it. If I'm generating, I would just think about one coordinate at a time. So X. And so anything let's say this is 400, anything that's greater than 400 would automatically be legal. So if this thing has an X position, let's say of 400, or anything higher, there's no way, regardless of its Y position, it would be interfering. Whoops. There's no way that it would be interfering in the box. Or if its X position was less than 200 over here, we wouldn't have to check it. Because that way it would be like, well, we know it has to be legal, and we know it has to be legal. And so the only time we need to really check, and so then you would just say, okay, the coordinate's automatically good, would be if it were in here. If it had an X value between 200 and 400, because it could be legal still down here or up here, but here it would be illegal. So it's like, if you might say something like, if target.x is less or greater than 200 and less than 400, then check its Y position. Then you would check the Y for whether it's legal. Is this within the legal? Or you could do it vice versa. It doesn't really matter. But that's essentially what we're doing with that kind of a thing, one way or the other, to generate a kind of a legal coordinate. So cool. Yeah, it's fun. I mean, because I remember that was like Kitty's question like 3 weeks ago or something, was, hey, how do I, and we're kind of back to that same idea of controlling where things happen and when they happen. So like some people had a game where like they just had a target going back and forth, let's say between these two boundaries. So you don't have to use collision to do that. You could just do this kind of a thing that David was just talking about, like just make sure that it generates within a certain space and that it has boundaries within that certain space that you're checking.
Mm-hmm.
Cool.
Yeah.
So yeah.
One thing that I just real quick that I was just remembering why I ever thought of doing the while loop version.
While is cool.
And I remember because when I was working, I was doing a project that wanted to generate a whole bunch of little characters inside some sort of a complex shape that was not, it wasn't a square or it wasn't a rectangle.
Funky.
And so and it wasn't a circle or something that you could easily just do a math check to make sure if it's inside or outside of that shape. And so it would basically ended up being, well, the easiest is, rather than trying to figure out the math that describes this weird curve, which would be insane, instead I'd be able to just test, sort of use brute force and say, well, is it inside? Is it touching this shape that's hidden behind the screen that no one sees? If it's touching it, then generate it again until it's no longer touching it. So that's sort of where the while loop gained its power, especially.
That's cool. Yeah, I mean, I didn't think about that. That's a neat way to do it, because it's like, while, like you're basically saying, while this condition is illegal, keep looking for numbers, right? Is that true? Is that kind of what's happening?
Mm-hmm.
It's like, while it's false, keep doing it until it's true or something. Yeah, that's cool.
Exactly. Yeah.
Nifty. And so you can kind of see how we're using these things that we've been working with, for loops and conditionals, to kind of develop the logic of the game. So it's like, if you can think about the game, articulate it in human terms, and convert that into logic, then you've got a really good shot at programming. So, and that's where those diagrams will be really helpful. So if you can kind of say, I want it to be here, because then you'll start thinking like the computer, like, oh, that means its X position has to be greater than this, less than this, that kind of stuff. Then you can convert that to a logical statement. Nice. Well, yeah, here's our sprite. This is our image that we'll use for our sprite sheet, just as a demonstration here. And so a sprite sheet can have any number of frames. This one just has a few here, just has really 3 frames. It's a square image, but it can be any shape. And I can show you some other demos of sprite sheets, but this is like I was thinking like the simplest, almost simplest. The simplest thing would be 2 images, but got 3 here. And let's just see how we do this. So I've got a images folder. It's just a PNG, just like a regular still image. And in fact, it's just it's one image. So the computer doesn't have to know that this is a sprite. It's just, that's what we're going to define in the code, but there's nothing in the PNG that's telling us that it's a sprite. Yeah. And then, so let's take a look at the code here. So this is it. Can everyone see that okay here? So we covered this in our recitation. A lot of people weren't there, but like, and so we can go over it with people that are in David's recitation or who weren't there, that this demonstrates some new Create.js objects. Basically, instead of doing a bitmap object, a create.js.bitmap object, which we've been using for all of our graphics up to this point, we would be using a create.js.sprite object, and we would be adding that to the stage, to add child. So just like we did with our bitmap, except it's called a sprite. The trick is that the sprite, you can't just make a sprite right away. You have to create a second object called a create.js.sprite sheet. And in order to create a sprite sheet, you need to provide either a really crazy long set of arguments, which is really impractical in this case, or you have to create what we would call a custom object that contains the data that would be used to construct the sprite sheet. So we're back to that Russian nesting dolls thing again, that in order to create an animated sprite, you need to make these three things. You have to create an object, and with our array, that's the square brackets is the way to create an empty array. The way to create an empty object is to just use these curly braces, and that's an object, or an object literal. And then you use that object to make the sprite sheet, and then you can take that sprite sheet and use that to make the sprite. Now this confused me for like years because the human language that we use is like, oh, it's a sprite sheet. Like, So another way to think about it would be that a sprite is one picture, one tiny picture at any given time. So when you're playing a video game, you might have a character that's running, but in any given frame, it's just you're seeing one image of the entire sprite sheet. So the sprite is basically a representation of one and only one frame of that sprite at one time. And the sprite sheet is the thing that the sprite is being derived from. So it's grabbing things off of the sprite sheet in order to make the sprite. And the sprite's what we actually see on the stage. And that just confused me to no end. I don't know. It just was like, well, what? I thought I made a sprite sheet. It's like, well, yeah, you did, but you need to make a sprite now. Why do I have to do that? Well, because it's separate. it's a separate object. So it takes a while to kind of get the hang of that. So in each of these things depends on the things that comes before it. And there are 5 steps to to get a sprite to actually show up and animate. And we'll go through those right now, but they're listed here in the comments. So the first thing we need to do is in our global variables section, we've got my stage width. This is all the same stuff that we've been doing. We've still got a hero, this empty hero. And then we're going to create a new variable here. A new variable here called just hero data or data. If you watch Star Trek Next Generation, right? Data, he meets somebody and she calls him Data. And she says, well, it's the same thing. He said, yeah, I know, it's just not my name. So hero data, I guess. So, and so it's just a variable. So create a variable named hero data. Okay, great. And the simplest way, then there's this very complicated, and again, this took me a really long time to figure out what all this was. And like we've been saying, you don't have to know it all. It's okay. It's like the first 85 times I did this, I was just copying and pasting like nobody's business. It was like, and I still do because it's kind of quicker, but I didn't necessarily understand exactly what I was copying and pasting. So it took a while to figure that out. So this is a good example of something that if you want to take the time to figure it out, it's actually really neat. I mean, because it all makes sense. And it's just that kind of nested Russian nesting doll syntax that makes all this work. So we start off with an object. So the simplest way you could do this would be something that would look like this, like create a variable named like David data. We wanted to make a David, and we would just do this. So this would be, you know, a legal data object. It would just be an object is a data type that is a JavaScript data type. Just like we said, you know, if we wanted to make an array, we could just do this. Now, whoopsie daisy. It knows that this is an empty array. So if we just do this, it's an empty object. Oops. So here you can see this is the first curly brace that's up here. This is the first curly brace. This is the last curly brace of the object. And all this other stuff just is what's going inside here. So all of this stuff here is jammed inside of this. And so that's why there's a semicolon here. It's just if we took that line and did this to it, and then we start putting stuff in here. So that's kind of cool. So that's just that container idea. And so in here, the way, did we talk about objects yet, David? In terms of an object literal like this? Not really?
Really, no. I mean, I don't think we've really created like characters in that way. We're sort of moving in a way, you know, like when we're moving toward like the make targets kind of thing, when you're making a target,
yeah.
we're doing it in a sense, we're creating an object that has a various properties, but we haven't done it in a very explicit way. That I think
we're not using that syntax. Yeah, right. So this is kind of a look a little bit deeper under the hood. Like I think, because technically, isn't it true that in JavaScript, like everything's an object? Or so everything's a function. I can't remember.
Yeah.
Something.
Sounds plausible.
Sounds great, right? Sounds cool. Yeah. So this is the way we wrote an array. So if we have an array, and let's forget about sprites for just a second, and we'll just learn about objects. So if we have an array and it contains two things, so quick review of an array. What's the length of this array? How long is this array? 2. Yep. So it has 2 things in it, cat and rat. What's the first index of the array? Anyone remember the index is always going to be, when we're using our for loop, it starts with 0. So the first thing, is, so if we did this, you know, console.log an array index 0, show me the thing at index 0 of an array, what would it show us? It would show us cat. And if we said, show us the thing at index 1, it would show us rat. So 0 is cat, 1 is rat. And if we said, show us the thing at index 2, it would say undefined. There isn't anything at index 2. So that's an array. And so an object is really, it's basically the same thing. Except instead of indexed numbers, it uses names. So check it out. So we'll go variable, you know, a zoo. Okay, and this is going to be an object. So that's our syntax for creating an object. So we'll call this like, you know, my zoo. Let's call it my zoo object. And we'll call this my zoo array. All right, so we've got my zoo array, has 2 things in it, cat and a rat. So here, my zoo object, we can do the same thing. We can hold, because the array just holds some data, and we can access it by using the index. So this is also going to hold data, but we're going to access it using the property name. And so we've already been working with properties, you know, like David was saying, we've already been doing that. .x is a property, .y is a property. And so we can do that here. We can say, let's create a property name. And so we'll call this animal1. and we're going to type a colon, and then we're going to say cat. Good old comma does this just fine. And then we're going to say animal 2 is going to be rat. So if I use my console again, console.log, my zoo object dot animal 1. So this would be returns cat. And this would be returns cat. Prints cat, yeah. So the difference, we're getting the same thing, but the difference is that we're not using an index, we're using the property name, and we're using dot notation. So if you were to look under the hood, that's when we go to the console and open up that object. We did that a couple weeks ago, I think. You see like the property name X or Y or regX or regY or rotation or scale. Those are all property names that have a value assigned to them with a colon. So if you were to look under the hood, that's what you'd actually see. So we could use anything for this property name. We could say, you know, we can change that around, but it makes it, in some ways, much easier to use than an array, because we just have to know the property name, which is a heck of a lot easier for us as human beings to know the property name. Otherwise, we have to come up with the secret code, you know, of what something is, what index something is, which we don't tend to remember. So you could store these things, they would both work, but how we want to access them is the difference when you use one or the other. So the nice thing about an array is that it's automatic. That, like, so in David's example of the target array, we just have, okay, I've got whatever number of targets. They don't have a name, just count down through them and throw them away if you need to. Like, we don't want to keep track of the names. We just want to keep things in the array, and as that gets bigger and smaller, we just want to deal with it. But with an object, it's more like, oh, I'm constructing this object that I want to have these properties. Then we're talking about, this is where the object is your friend. Mm-hmm. So essentially, we've already started to do this, like David mentioned, in our hero character, because we've created those custom properties, right? Like, what did we do? We had one called, well, we're going to do that in a second. But did we have some, we did some custom properties, didn't we, David?
Yeah.
I don't remember. What was an example?
Just even like speed X, speed Y.
Yeah, speed X, speed Y. Yeah, or speed, dot speed. Yeah.
Dot friend or foe. We just did. Yeah.
So if you think about it, like, you know, for a game, you could do something like variable player equals object. So you could start thinking about like an RPG or something. You could say, you know, strength 18, intelligence 7, name elbow, you know. So you can just start to add these. I'd probably want to put a string, make that a string. It could be a variable. I mean, you could also have a variable. So, and I don't know, class, you know, fighter or something. So, like, what, you know, you could also have like a friend or foe, you know, property or something like that. Alignment or something. So this is just the way an object works. It's really cool because in a way it's kind of a simple idea, and you can just call these things whatever you want. So anyway, that's an introduction to an object.
Yeah, real quick, one thing you might also consider is that you can also nest, so you can put a lot of things in an object, and you can also nest things within that, so that, for example, you might have, so it can be more complex than numbers and this. There could be an array that's housed in there, or it could be another object inside of it. So you could have, so for example, looking at that, my zoo object is a good example. You might have a property in there that's called animals, and it holds an array of animals, and each of those animals is an object that then has properties of size, weight, feeding habits, etc. So that then you can also like go in a sort of a nested level, so you can talk to any of those individuals, but then you can also talk to them like you can talk to arrays. So you could say, my zoo object dot animals or dot rpals, and then you could say rpals dot size, rpals one dot size, that kind of thing. So you can go in and sort of be able to programmatically find all the data that's stored into that object.
Yeah, that's great. So yeah, you could either refer to an external array like this, or we could do this. We could basically put an array directly in here and say, the same thing. Those would both work.
Yeah.
So this would be, so if we said my zoom object dot our pals bracket 1, that would refer to cat. That would also return cat.
Uh-huh. Yeah. Well, here actually,
so it would be like this.
Yeah.
Yeah.
Do one thing here. Oops. Oh no. Why don't you go ahead and
on this? Okay.
I'll request access.
Oh yeah, screen share.
Because I don't have your code typed on mine.
Okay. Share. Where's my
just share screen
remote control option? Oh, okay.
Yeah, just share deny request.
Okay. Okay. Oh, there it is. Remote control. Okay.
Cool.
I approve.
Hey, thank you. Okay. So I'm on Miles' screen here now. So what was I thinking? Oh, yeah, like this idea here is that actually another option would be that you have in this, you create objects within that. Oops. So you could go like this, and you'd have your object that is going to be called, or that's going to have like name is cat. It has size is, and I'll just do like 2 things. Size is medium, and then same thing for the other. So we say curly braces, we say name is rat, and size is small. So something like that. And this is where sometimes you'll start seeing people break things into like, break it onto separate lines. So it becomes a little more obvious where and maybe I'll let Miles, you do that because it's a little laggy on my control here.
Okay, all right.
But that was kind of that's the kind of idea where, we have now an array of R pals, and each element in the array is an object itself. So that then you can go in and talk to my zoo object, find out like how many pals there are in R pals, and each of those pals has a name and a size, and it might have all sorts of other things as well. So it becomes now this really sort of interesting database, really. Or in other places you might use it like it as a dictionary. People call that kind of a thing a dictionary as well. And so it's really just a structured way of having all that information in a way that you can read easily as a human, but also is then still traversable in a pretty easy way via code.
Weird. Wasn't letting me. Anyway, yeah, you can kind of just see it like, okay, here's the, or you do it like this, so it's an object. This is the way I would do it, not like that. So, there we go.
Yeah, you just gotta always make sure, like if you're creating it or if you're editing it, check out the commas, because there's going to be commas that separate each of those individual elements, but no comma at the end and stuff like that. Those are just commonly trivial. And it's really easy then to just see, like, you look at that, and even if you don't know much about code, you can say, oh, okay, I think I know how I can add another element in there, how I could add another pal to our menagerie, because it's just copy paste, change the values.
And this is the kind of thing, like if you go on to work in this field, you know, like programming things, this is like kind of what you're going to be doing, something like this in some form. A lot of times is like a database, like David said, you know, first name, last name, student ID number, you know what I mean? Those are all property names. So, you know, if we want to be horrible, we can think about ourselves. We're all objects in the SOU database, you know, so we exist there, and we would have like student ID number, address, all those things would be kind of stored in a database. And, you know, faculty or student or senior or junior. So that's all this idea of properties. So those are all property names, and then the values are going to differ from student to student, but the structure of a student would be the same. So yeah, cool. So objects, yeah, cool. So if we go back to our spreadsheet, let's get rid of all this. And so we've made an object here. So here's the beginning of the curly brace, here's the end of the curly brace, and there's the semicolon. So this object is going to contain three properties. Images, frames, and animations. And like David alluded to, it's going to actually contain, each of those properties is going to contain nested within it another thing of some sort. So images, the property images, is going to contain an array. Annoyingly, it's an array with only one thing in it. So that's kind of annoying. But the reason why it's an array is that you could actually make a sprite sheet out of more than one image, which actually is kind of cool. I mean, that gives you some kind of diabolical potential to do weird stuff if you wanted to down the line. But for us, it's a little bit of a red herring to have this array with one thing in it, but there it is. So it's an array, and this image path is just like what we've been using, exactly what we use for bitmaps. So it's the same thing. The frames property contains an object. So nested within this overall object is another object. The frames object has three properties: width, height, and count. So width is 128, height is 128. What those are, it's the width and height in pixels that we need to cut this sheet into. So for Gramp Stamp, if we look back at this image here, what it's saying is that this is the image, go 128 pixels this way and 128 pixels this way, and cut that image out and show that in the sprite. And so each of these frames is 128 by 128. They don't have to be uniform. It makes it a little easier to code it. So this is just, so the width of our frames is 128, and we're telling it there are 4 of those. So it's kind of a no-brainer for this, because it's the only way it could cut up that, given the size of the canvas is, the size of the image is 256 by 256. So it's, you know, but we're saying, yeah, 128, do it 4 times. So there are 4 128 by 128 frames, one of which is blank. So the last object, or the last property, is animations, and it also contains an object. Okay, so here's the beginning of the object up here on 54. Here's the end of the object on 62. But where we get super meta here is the animations object contains 3 properties. Now they're using a string, which is fine. I think it just makes it a little easier for some of the code to work. I think I've tried it without it, and I think it got a little janky. So use a string, okay, for the property name. But the walk property contains, yes, you guessed it, another object. So we're going, the hero data object contains 3 properties. The frames property contains an object. The animations property also contains an object. The walk property of the animations property contains another object. And so we're just going, nesting. And that's what's kind of cool about this, is that you just have to kind of keep logically going, but it actually does make sense. It's just going bit, 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 bit. We're just going a lot of levels down. So the walk property contains an object. The walk object contains two properties. So you can kind of see how this is working, right? So one of them is called frames. That contains an array. Whew. Okay, so I think that's it. So I don't think we go any deeper than that. So the walk property contains this object here, and the frames property contains an array. Well, what does that array hold? It holds the frame numbers 0, 1, 0, 2. Just numbers. It holds the numbers 0 and 1 and 0 and 2. They're just numbers held in an array. And if we look back here, what that means is it says play frame 0, play frame 1, play frame 0, play frame 2. So 0, 1, back to 0, and then jump to 2. So he goes this foot up, back to stand, this foot up. So he's going to have this kind of like kind of a little walk. And it's only these 3 frames, but it's saying the order in which to play those. So that's the way we define an animation. So 0, 1, 0, 2. So it's going to go. And the other cool property here is speed, because speed lets us, because we can't mess around with the frame rate. We could, but it's a terrible idea generally, because everything's running at once. And so you want to keep your frame rate consistent, but you just have to make, sometimes you want to have something run slower, you want to have it run faster. And that's where speed comes in. Speed is the rate at which it should play things back, these frames back. So if we were to, the default is 1, which means play each of these frames for 1 tick. And so since our tick here is 30 frames a second, it would go, this would be playing in whatever 30 divided by 4 is, like, basically pretty close to like a 1/6 of a second, which would be too fast. It would just be like, it wouldn't make any sense. So we're slowing it down. We're saying, no, to 0.2, which means, so hold it for, I forget how what is the math here? Why is it 0.2? So if we did 2, it would play it twice as long. And 0.2 is going to be, I guess, it's going to hold it for 5 times longer, for basically five frames at that, 5 ticks. So the next animation here is called idle, and it's a super complicated animation. It's just saying play that 0 frame. So there's not really much of an idle, it's just a still frame. So you could have more complicated stuff. And I have examples, I think, in here of more complicated things. But this is just to kind of give you the idea that you can define these. And so we could add another animation, like if we wanted to have like fast walk, we would just say like, oh, just play frames 1 and 2. And so it would just, make things even a little crazier. So that's our object. So once we've defined this, all we've done is define an object. This is not attached to anything yet. It's just a kind of a statement of numbers and names, basically, and strings. This isn't doing anything yet. So the next step is to do something with it. And so still in our global variable section, we create a variable called hero sprite sheet. So this is also just an empty variable. Not doing anything yet. Okay, well, here's our init function. Same thing, stage width, stage height, ticker, blah, blah, blah. So nothing new here. This is exactly what we've been doing. So now we're moving on to step 2 of creating our sprite sheet. So now we have to create our actual create.js.sprite sheet. So now we're actually going to make something. This object is just sitting there as a data. It's just holding data. It's not doing anything with it. But this is a create.js object. It's called a sprite sheet. And you have to have the 2 capitals there, double S's there. And it's taking as its argument hero data. Well, what's hero data? It's our object. And so it's able to go into that object and pull all that information out that it needs to construct a sprite sheet. Once we have a sprite sheet constructed, we can stick that into the next thing, which is to take our hero, and instead of giving a hero a new createjs.bitmap, we're going to give it a new createjs.sprite. And that sprite needs to have a sprite sheet in order for it to work. And that's why it uses this that we just set up here. Then at some point, we have to tell it which animation we want it to play of these. You know, we might have 20 animations or 10 animations or 2 animations. We have 2. So we're saying, all right, when this program starts, go to and play the walk animation. So go to and play is a method of hero or createjs.sprite. Createjs.sprite has a method go to and play. Position width, and then we add it the exact same way that we did our bitmap, my stage to add child hero. So that line is exactly the same as what we've been using for bitmap. And then it just draws it. So if we run this, it should work. Maybe, I don't know. Maybe I screwed it up. Nope, there it goes. So he's moving. So you can see like what happens then if we start to play with the speed. So if we go back and say, let's set the speed here from 0.2 to 1. Save, oops, save and reload. Oops, I messed something up. Speed 1, save, reload. What's going on? What have I done? Unexpected identifier, 48. Oh, I think I tweaked something out here. 48 images. Oh, I somehow conspired to take that and move that out of here. No idea how I did that. Superpowers. So that's with a frame rate of 1, which is pretty disturbing. So I don't know, that might be a bit much. So, and if we want to get even more disturbing, we'd say, oh, that looks great. Let's make it like 2. Well, what did I do? Or 0.5. So you can, anyway, that's the speed property. We're just changing the value of the speed property. Cool. Or we could say, well, what happens if we change the frame sequence? So if we get rid of these frames here, it's just going to do 1 and 2, and we can slow it back down.
You could also do things, you know, I imagine like if you did like 1-1, or like stay extra long on 1, so like a 1-1s, so you could have it give it a kind of limp, that kind of thing, so you can control that sort of internal timing by just the order of the pattern there.
It's kind of neat. Yes, exactly. So he's got syncopation now. So has he? Cool. So it's pretty neat. I mean, it's cool because it's a really good way to actually learn this JavaScript syntax to kind of get it down, so it's pure kind of logic, but for something fun as the result, you know. And you could have that be a separate animation. So like, let's set this back. So let's leave that the way it was. And then let's set the speed back to 0.2. All right, so that's what we started with. And so we could just go down here and define a new animation. So if we're going to add an animation, we want to have a comma. And then let's just call this stutter. and colon, and we're going to have an object. And so we're going to add our properties, frames, and an array. And the array we're going to have what we had 1, comma 1, comma 1, comma 2. And then we have a comma between the properties. And we would say speed 0.5. Okay. And we don't have a comma after the last property. And we don't have a comma after the last object in this object. So that looks good. And so instead of doing walk, we'll do stutter step. And we can go back, and maybe we need to set this back down to 0.2. And again, we can just call some, now we can still call walk. Oops. Now we're back to walk. So, in the next examples, we just set up some conditionals. So saying, oh, if this condition, play this animation. If this other condition, play this other animation. And so, generally for this, you'd want to tie that to the keys. And yeah. So, but this is just an introduction to the way Sprite Sheets work. So, yeah. Huzzah. We're done. And let people have questions about that. I'm sure you do, but I would just try to start off with the code and go to town with it. Oh, we got to do sound. Oh my God. All right. Well, anyway. But that's Sprite Sheets. Cool. Anyone have any questions on that? All right. Well, we can talk about it on Wednesday too if people are getting fired up to do it. So, like if you're kind of more artistically inclined at this point and less codey, you can focus on doing some really awesome Sprite Sheets and animations and stuff like that. But that's a fun thing to kind of add into your toolkit there. Oh, what if I am Cody? That's right. Well, then you're gonna have to be extremely Cody. Yeah, just you be you, as they say. So give it your best go.
Okay, I'm back. Are we? Am I sharing my screen?
You are sharing your screen.
Okay, beautiful. I had a little hang up there, but I think things are happening. Okay, so back.
I'll be right back. Sorry, just keep going. I'll be back. I shall return.
Okay, great. So if we want to just look in on Moodle for a second, looking towards what we're going towards at the very end is week 10. We have now posted called a final version of the game, which is going to be due on Friday of next week. So we have all this week and all of next week will be the final version. So it's at the end of week 10. And what we're asking you to do is, this is as a Moodle forum. So if you just click into there, you'll see it. And it's asking you to submit this is a forum post. So you would just add a new discussion topic that would be, and then you could just be your name as the discussion topic, or the name of your game would be great if you have it. And then what I'm asking you to do is you'll post a link to your game, hopefully working live on the internet. And then also just write up a paragraph that describes your goals, design ideas, challenges, etc. And then as games get posted in there, keep checking back and see what other people are doing, and do post comments. I'm doing it in separate threads so that people can post comments on each other's games as they pop up, because it's a lot of fun to see where everyone got to with that. So that is due Friday, June 12th at 12 p.m. So that's actually at noon on Fridays. We're looking for those to be done. So that will give time for this week to be adding in any sound elements and any of the stuff we talked about today, as well as all of next week, Monday and Wednesday, to be debugging and getting things in a final ready state, ready to post up there so we can all share that together. All right, so the next part that I want to talk about today is going to be focusing in on sound. And back on the Moodle page, there's two areas here. There's some lecture notes that I'll sort of step through in just a moment. Those are available to you right here, as well as there's a regular tutorial thing that you can download for Project 1.5. And within that, you'll see that it actually has two parts. Let's see if I can bring it here in a way that's useful. That is going to be, one part has to do with sound and Create.js, and the other is a demo that includes sound, but also has a much more elaborate state engine and some other things like that. So you'll see when you open that up. But what I want to start with now is dealing a little bit with just thinking about sound and how it's going to work in Create.js. So let me pop us over here into this little bit of a presentation. Hopefully you can see it here. These are the slides that you'll be able to see on the Moodle page there if you want to follow along there or check this out later. So we're going to be thinking about events and interaction, which we've already done a fair amount of because we've had interaction with mouse input, potentially clicking on things, keyboard input, certainly with the key monkey, is dealing with events. And we've been dealing with interaction as well, but we'll look at that a little more explicitly because it's important in terms of how we make sounds happen. So if we think of events, it's like something happened. An event happens at a discrete point in time. So some sort of an input happens, and then we create some sort of an output based on our internal mappings. So we have that user input. My system has run out of memory. That's fun. Let me know if I'm getting lag or anything like that. I need to quit out of some stuff here, it looks like. Oh, fine, let me quit. My apologies, 1 second here. I'm going to force quit Blender because I'm sure that was killing us here. Okay, my apologies. The idea is you have user input of some sort, like there's an event that's detected, and then you have some sort of a coded response so the computer knows how it's going to respond to that. And that really defines the very minimal idea of interaction. Yeah, you do something, the computer does something in response to that. And as you develop in code more nuanced responses to that input, things that do things more subtly, you might start thinking of that interaction as having properties that you might call like more intelligent, natural, beautiful. It's like well-designed interaction comes about through knowing what types of inputs to be looking for and how to have a really sort of subtle, nuanced response to that. But events can be triggered by a lot of different types of user interaction. So for example, key was pressed, a button was clicked, mouse was clicked or the mouse was moved, the screen was touched if you're using a touch screen. All those things can be user interactions that can cause events. And there's a key kind of a structure that that you can use for this kind of a thing. Built into JavaScript is this add event listener, which is a function that can be added to almost any object in JavaScript. So my stage is an object. You know, we created my stage and set it equal to a canvas element. And then we're adding in this method, which is predefined in JavaScript called add event listener. And it's going to be listening for, so that add event listener listens for events and does something in response. So the first thing you feed it is what type of event is it going to be listening for. And then the second is the name of a function that's going to be called when that event is heard. And there are a number, you can't just type in anything you want in these. There are some predefined things based on what type of an object it is. But stage mouse down is one of them, stage mouse up, on mouse move, I think, and there's some other ones like that, all sorts of things. Keyboard inputs can be part of that as well. We've handled the keyboard input for you when we've used the key monkey. But so in here, stage mouse down means that moment at which the mouse gets clicked, as opposed to stage mouse up would be the moment when you let go of the mouse. And those are things that normally we just don't even think about, the difference between click down versus click up. But that can be important. You want to actually have the action happen when you let go or when you first click. It's all those things give you that possibility of defining interaction where, let's say, you wanted to click on something, but you wanted to allow people to change their mind before, like, oh, wait, I don't actually want to click that, so that they could click it, then move their mouse away from that object and then let go. Then if you didn't use the stage mouse, if you use stage mouse down, right when you click on it, the event would happen and then that function would be called. But if you clicked with the stage mouse up, you click down, and you decide, oh no, I don't want to do that, you could mouse away and then click up, and then it won't trigger that action. So there's things like that you can start thinking about how that interaction actually happens. So then once that event is detected, is heard, it will call out a function. And these are functions that would be defined by you. So handle click is just an arbitrary function name that I've created that handles something when and does something when the mouse is clicked. So that's just a way of being a little more explicit about some of the stuff that we've been dealing with. So if you wanted to, for example, to add something where, like, if you were to click on your hero, you could say hero.add event listener, and then and be able to add actions and events that are detectable on the hero itself, and do something in response to that. Oops, let me see here. Events can also be triggered by something that the computer does, and that's one that we're going to see here in just a second. We're dealing with sound and preloading. So for example, when a file is loaded, that could be something that is an event, and then it triggers something else to happen. So we'll see that here. So to do sound and create.js, we're going to be needing to do a few different things. We need to get sounds. We need to either download them or make them and place them in a folder that's going to be accessible. And here I'm calling them sounds, just like we had an images folder. So let's look at that for a second. I'm going to bounce out of here and come into show you, where did it go? Here it is. Okay, so here is what you would download if you download the project 1.5 from the Moodle page. It will come up with two folders. I'm looking in the sound and create.js one right now. So in here, there's the images, there's the JS folder, but then there's also now this sounds folder. And inside of that, whoa, there's all sorts of sounds. So there's a bunch of sounds in here, mainly some bell sounds and some scraping sounds and wind sounds, some screams, all the good stuff you need. So that is, and you'll notice in here that I actually have two file formats of each of these. This is getting to be a little less necessary. You can get away in most situations by having just MP3 formats of sounds that you find or that you create and use. OGG is another compression format, but it is an open source one. And MP3 is technically owned by someone, and so browsers have to pay to be able to use MP3 formats on playback. So there were, at one point in the not too distant past, there were some formats that, so MP3s wouldn't just default play on some browsers. So you had to have alternative formats. Today, I think that's pretty much obsolete. So you can pretty much get away with just MP3 formats of things. So in this case, so we have sounds here, and then we're going to be able to be accessing them in some different ways. So if we look in here, we see we're going to get them, we put them in that folder, so we'll be able to find them. Then we're going to preload them. And so preloading is really necessary now when we're talking about sound. It hasn't been as necessary because images typically load pretty quickly because the file sizes are typically fairly small, unless you're doing something really, really high res, which you probably didn't need it to be that big of an image. But the issue comes about when if you start to call something before it has been loaded into memory, the computer just will fail in some way. Either it will give you an error saying that it couldn't find it yet, or it hadn't loaded it yet, or it just won't do anything. So if it's trying to load in a sound, like you say, you click a button, and in that moment when you click a button, you tell it to load a sound and play it. If that sound happens to be, even a couple of megabytes, it's not going to be able to instantaneously load that and then start playing it at the same time. And so typically what will happen is that the first few clicks of something that is supposed to cause a sound will be silent, and then eventually it gets loaded into memory, and then the next few clicks you're going to start making sounds, which isn't exactly what you're wanting to have happen in the coded environment. So we use a preloading system to be able to make it happen in a format that, or in a timely manner. So what we do, and this is copy pastable, but it's worth just sort of seeing what it is. And these are in those examples that are on the Moodle page now, is that we create a load queue. And that's a create.js object, just like sprites and sprite sheets and bitmaps and all that. And what it is it's a queue, like a list of files that are going to be loaded in. So we create our own version of it. We just call it, say, queue of our queue is a new load queue in create.js. And then this line deals with that extensions of whether it's going to be an MP3 or other things. And so this says that if you don't find the file that's listed below, then go looking for the same file name, but use the MP3 format. Or if you can't load the .ogg version, try the .mp3 version, is really what it's saying. And then the queue, we're going to install the plugin for create.js.sound, which means that the queue knows it's dealing with sound files. And then we add an event listener, just what I was showing you, that event listener thing. And here the event listener is that the load queue has a property or something, I'm not sure what it is, a state, an event, I guess really, an event called complete. And when the load queue is loaded, it says complete, I'm complete. And when it is complete, you say handle complete. Or so you do the handle complete function, which isn't shown here. And then the last part is that we add files to our queue. And you do that by one of a couple ways. If you're just loading a single file, you would do it the way that I have here. So you'd say queue.loadFile, and then you're loading in, look, there it is, an object. So curly braces, it has an ID, which is the name that you're going to call it. And then the source, which is the location that it's going to find that file. And there's some other things you can also put into that as well. But that's the basic idea. If you're going to do more than one file, it's very similar. It's except that then you use what's called a load manifest. Like like if you think about like a ship has a manifest or a plane has a manifest. It's a list of all the people that are present on there. So here it's all the files that are going to be present in our queue. So this is typically what people are going to use because usually you're going to be preloading more than one file. So you do a load manifest, and you have an array of objects now. So the manifest is an array. You see the square brackets, and then inside of that, each element of the array is in the object. So let's see what those different elements in there. We saw them already, but I'll explain them a little bit further. So there's the ID, which is going to be a name that we're going to be able to call later. And that can be the same as the file name. Often it's good to keep those things sort of simple and keep track of that. But it might be some other name that you want to call it. Like if your file name was some complex like bell on top of a church bell, or church bells on top of the tower in Notre Dame, or something like that, .mp3. Here you might just call the ID bell because you want to just have something easy that you can call it. So that's what the ID is. Next thing is the source. The src is where it's going to find it. You'll notice here we have sounds /, so it's going to go into the sounds folder, then look for that file. And then the last element there that I haven't talked about yet is a data argument. And that's something that can be used to represent the number of instances of the sound to preload. And so this is about playing the sound on top of itself. So imagine, the classic sort of game version of this is like a gunshot or something like that, maybe, that you have a a gun sound that you're going to be going to something you might fire rapidly. If you just have a single instance of that sound loaded, it's just going to play it back once, and then if you call it to play it again, one of two things will happen. Either it's not going to play because the file is currently busy being played, or it's going to cut off the sound and then start it over again. So either way, you'll get some sort of a hiccupy experience, an experience that's not really what you're most likely wanting. So data allows you to have a certain number of those that can get loaded up into memory and played on top of each other. So you could have a rapid fire of any sound that does ding, 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 and each of those bells is going to have all the full decay of the sound. The full sound is there rather than being truncated. So you can give it that data property. If you don't, it will only load up a single instance. And then playing, so once you've done all that, you've done all this preload stuff, the playing is pretty easy. You just call a play function, which is createjs.sound.play, and then you give it its ID. And the ID is just the name that you associated when you set up the preload. So you can give it some additional parameters, and I'm going to go through these quickly, but you can give it, so the first parameter would be the ID. The second one is an interrupt method, which I typically don't use, but I believe that's the idea. If another instance of this is called, what do you do? And there's a couple different versions of that. Like you don't do anything, you just let it take over, or you let this has to play out and it can't be interrupted, etc. There's some versions of that, and you just Google create.js sound play to find those. Next one is a delay of how many milliseconds do you want to wait before starting. So you could have it call the play, but then actually wait 1,000 milliseconds, so 1 second, and then play the sound. The next thing is an offset. So like, where do you want to start in the file? So if you want to start at the beginning of the file or some period of time into the file before or when it's happening. So you could use some of those things, those timing features, to get things to sync up very precisely with some sort of like an animation that had something that didn't happen right on the moment, but it's like maybe let's say you had some complex animation that was like the guy pulls out his sword and then swings the sword. It could be that there's that delay that you want to set in a delay so that you start the sword swing sound at the same time that animation starts, but you delay the sound so that it happens at the right time. All that stuff could happen with those kind of delays. Another thing that people do, I haven't really taught it this way, but as you get moving more and more with game development, sometimes people use audio sprite sheets, or the equivalent of an audio sprite sheet, which would be you have one sound file that's however long it is. It's a 2-minute long sound file that gets loaded in, and then you just play different regions of that to call your different sounds that you want to play. So that's an option as well. So then there's a loop. So how many times should that loop? 0 would be none. Twice would be 2 times. -1 means an infinite loop, so it's like a background sound that you want to just keep playing over and over again. You put it on a -1 loop, and there you go. A volume, which is a value between 0 and 1, and then a pan. Not all browsers support it the same, but if they do, -1 would be all the way to the left, 1 would be all the way to the right. And then you can do all that when you're playing your sounds. So you can call these things separately rather than in this sort of complicated long list of properties. It's like, which value is that? I don't remember. You can do that separately if you call the play instance as a variable. So you could say var wind sound is a create.js sound play of wind. So that actually starts playback of the sound. But it also then means that we have this thing called wind sound, which is the instance of that sound playing, and you can then access its volume properties and access its looping properties, all those things that I just described. You can access right at the beginning or later on down the road. You could say like, play the sound, and then when something happens, make the volume go down softer. And then, so let's jump over and look at a couple examples. And these are all on the Moodle page. As we do so, there's two caveats, and these are the sort of annoying things about working with sound and working with preloading. One is that is dealing with preloading. Often you're going to need to push files up onto the server because you might start to get cross-domain errors, which it won't allow it to load unless it's housed on the server that is making the calls. And so typically a lot of these things won't work locally. You just have to push them up to CyberDuck and then they will be working up there. There's some more convoluted ways and to get it to work locally, but they're a little bit more challenging. There is a version on 1.5 that you'll see. Let me see if I can find it. Well, that other folder that had the, what was it called? Levels, sounds, and states. So this version in here has sound working with sort of to get around all those cross-domain issues. But it's a little too in-depth to spend a lot of time focusing on those nuances. So that's the one annoyance. The second annoyance is a fairly new annoyance in that Chrome now is blocking sound from happening unless it is initiated by a user interaction. So that's so that when you open up a web page, it doesn't just start playing sound at you unless you somehow tacitly accepted it, so to speak, by like clicking on something or interacting in some way on the page. And you can see some value to that, but it causes a little bit of hiccups. And there are workarounds, but for right now, the easiest is just to make it so that the first sound that you want to have happen be tied to a user interaction, so tied to a click, and then all your sound will be activated. And we can try and explore some of those other workarounds later or maybe on Wednesday. But so to that end, I'm actually going to start in looking at example B, which is the background and on-click sound in that sound and create.js folder. And it has everything you need to be able to load in sounds, preload them, get them playing as backgrounds, as well as get them playing as on events, so like on click events. And you could plug this into your games. I've sort of separated these out as to just examples dealing with the sound. So you just plug and play these into your own game versions, rather than having it, just because our games are getting long enough that then to see where all these little elements are would be jumping around a bit too much. So let's see what we got in here. We have our create.js library. In this case, I was loading it locally, but you can use it with the HTTP access like we have been. And then this is all the preload stuff that we just talked about. So we create our queue, we install the sound plugin for it, we add a listener that when the queue is loaded, we run this handle complete function. And then we have our list of files that we're loading in. In this case, I'm just loading in 2 sound files, a wind sound file and a bell sound file. And then we have I created our stage in an init function, just like we normally have been. And I've added here an event listener, which was the stage mouse down. So when you click somewhere in the stage, it will run the handle click function. And that is used to play the bell sound. Our handle complete, which was when our preload is done, goes and is supposed to run this this handle complete function, which just starts playing the wind sound. And you'll notice when we go to the demo version of this, that's only going to actually start once I've interacted with the page. So once I've clicked, then it turns on the audio engine, and then the background wind sound is going to play. So let's just see that in action here. And yes, in JavaScript, everything is an object. Yay! So I'm going to go with B, background sound, on-click sounds. So loads up, there's nothing to see. It's just nothing there. Hopefully the nice sound sharing is working. Apologies if the volume is high because those things can be different. So when I click, I should get a bell, and then it starts the background wind sound. Okay, I got a ding, and I have wind is happening now. Everything is going on as expected. If I do an inspector, we'll see that error that I'm talking about, that the audio context was not allowed to start. It must be resumed or created after a user gesture on the page. So like I say, there are some workarounds, but that's why it didn't start playing instantly. So now every time I click, we hear a sound, and I have multiple instances loaded up there. I have 10 of them, so I can click a lot before it's going to cut off. But if I didn't have that property on there, you'd hear it stop and then start the next one, and it gives you a less sort of believable sound experience. So that's that one. And let me know if there's questions. I see there's some chat stuff happening on there. Not sure if there's, so let me know if there's anything sound-wise. The next question, or the next version that we have, is dealing with multiple on-click sounds. And this is really not, really all that I've shown you already is everything you need to be able to do all the types of sounds that you might want to be able to do. Now this is just sort of playing with that a little bit, seeing what some extensions of that. So for example, this next version takes, it has multiple different sounds that might be used when you click. Sorry, there's some background sound here we got going on. But you can see that it's, so I have a handle click, and each time you click, it chooses a random value that's going to be making a switch case, and it chooses one of these three sounds. So is it going to be a scream? Is it going to be a bell, or a different scream? And then it plays that. So you can kind of see that structure of how that's happening. There's nothing different about, like, you know, this could be used for anything. We've used switch case before. So there's nothing unique about it in terms of sound, but just showing another example of the type of interaction you might have there. So then on this one, I'll just do it again, web pages, multiple on-click sounds. So now when I click, there's an exciting thing. You never know. Is it going to be a pleasant bell, or is it going to be a blood-curdling scream? And it's usually the scream when you start, just because, hey, yeah. Okay, so screams, different scream. By random chance, I'm getting mainly screams, so my apologies. There's a bell. Oh, okay. So a wide variety of screams and other things. The bell is a little more pleasant, yes. And then the background wind sound going on there. So again, just to see that briefly here, all we're doing is we are having a switch case, a random and a switch case, that's setting a variable named x, that's a local variable, to be equal to different strings, which are associated with the IDs that I had set up here: wind, bell, scream 1, scream 2. And then whichever one of those is chosen, it then says play the sound X, like that. And there you go. So there'd be other ways to do that. You could have had this create.js sound.play line happen in each of these cases, but I thought it would be it's a little cleaner there. The other thing that we could do that we didn't do here would be to say access those sounds later. So let's do that with the wind sound. So if I said, I could say wind sound gets that, and then I would have a global variable called wind sound, and that would allow me then to have access to wind sound and change its volume later. I didn't have an example that did that before, but just showing that same thing. So that then, let's say you had your wind sound, and every time you clicked, your wind sound went down in volume. So then I could access that on the click. I'd say winsound.volume is minus equal 0.1. So every time the volume is going to start at 1, and then the wind sound should get successively quieter each time by a tenth. So that would be a good option. Then yeah, I think that's really the main stuff that I want to show. There's also a more extensive demo called Z in there that has a bunch of different states, but it's also a bit kind of convoluted because it's using some older animation systems where you're using tweening, which means like you define a starting point and an ending point, and it moves between those based on a tween, which is a way of doing that, not where you're not really in control of where it is at any given moment. You're just saying create.js, take over and sort of slide over to this new location and stuff like that. And it gets a little more complicated in there, mainly because of that stuff and some timing stuff. But just to sort of show it there, it's this thing. There we go. And so it builds these little, it's called ego because there's lots and lots of pictures of me. So every time I click, a bell happens, this picture of me sort of jumps out onto the stage, and then they crawl around with these little clicking sounds. And then when it goes away, it goes kind of slides off the table sound. So it's handling each of these as sort of separate elements that have sounds associated with them with each time. So you can have multiple of these. And sound that's happening as a background, as well as event sound, as well as sort of sounds that in a way are sort of associated with each of those characters along their life. So that's sort of, so take a look in there if you're interested. But really the key things that most likely going to want to be able to do are sounds, a background sound, and maybe a sound on an event. So what we've looked at so far was more associating these sounds based on like a click event, but that could be associated with any other sort of an event. So if we were to just look at this, and really any of these more sort of games where we're at in the games, here, for example, check collisions, I would likely maybe we'd have a different sound whether you hit a friend versus whether you hit a foe. So maybe you'd put a scream in here versus a ding in here when you hit a friend, or when you hit other way around. Hit a ding when you hit a friend and a scream when you hit a foe, for example. And that could just be done in your check collisions, and you'd have your, if you had everything else set up there, then you would just have your create.js, js.sound.play, bell, like that. And a similar thing down here for this, and that'd be your screen 1, for example. So that would be most likely where the obvious places to put sound would be, other than having them in your background, like as a background sound. So let me sort of leave it, since we're getting close to time, let me sort of leave it at that and see what questions that you got related to any of that or any of the stuff that we've talked about thus far. Okay. Well, we'll have certainly time on Wednesday to fill you in more on these things, and also, yeah, just to point you in the direction, there is also in the folder that you can get from today, from the Moodle page. Let me find where it is. There's the Project 1.5 tutorial code, and this you'll find is a pretty cool but also pretty elaborate version of sort of the game as is. So let's just sort of take a look at what it does for you. And open it up here. Okay, so it has some levels. Oops, make it a little smaller. It has sounds on events. So when you hit something, it chooses one of a few different bell sounds. It's able to collect stuff. There's also some more interesting motion happening that Miles developed with gravity going on. So there's 3 levels. Well, each one gets more and more complex. You'll notice that there is also a background sound that we're not hearing right now. But when the game loops over and starts up again, we'll hear it. Makes much more dreamy, eerie. And that is because of our friend that Google Chrome made for us. So if we inspect the page here, we'll see that same error popping up here. Failed because user didn't interact with the document first. That stuff's happening. So once we have action happening, then the sounds happen no problem. Once you start moving a character or interacting, and then once we looped back to the beginning, it started playing again, and it works just fine. So that's not for you to worry about. We'll sort of debug that a little bit and try and get it happening in a reliable way. But a simple way would be to have some form of a start screen that basically the very beginning of your game is just like, welcome to my game, click here to begin. And while it's doing that, it could be doing the preload stuff. And then when you click, then you start showing all of your assets, and then go from there. So that'll be a quick thing that maybe we can all add into that version as well. But that's, if you're interested in trying to get more of those levels happening, play with gravity and stuff like that, feel free to check that out. And really, it does a good job of having multiple different states present. That then, like, you're in the pre-game state, you're in level 1 state, you're in what state are you in, really spells that out. Are you in the loading asset state? Are you in the assets loaded, going to start game state? Goes to a pretty granular level like that. So it's good for that kind of stuff. Nice. So anything else, Miles, you wanted to?
Nope, that's good. I think we're good. I mean, I think the state thing, I think we probably won't have time this quarter unless people are ambitious to do it.
Yeah.
We should try to figure out a way. It's like you guys don't have to deal with like a state machine or something like that. So but if you want to do kind of more elaborate sprite sheet stuff, we'll talk about state, animation state, stuff like that. But
yeah.
Though the examples are there if you're feeling fired up and sassy about it. Check out state.
Yeah.
Finite state machine. Woohoo.
Yeah, and the other very minimal kind of state machine in a sense that we have, it's not a true state machine, is where we have, if you think about preloading, and then using, once the preload is done, that then runs your init game function, for example, and then that then runs the next thing. In a sense, those are basically states that you're controlling. So once that thing happens, move on to the next state. It's not as explicit as a true state engine, but you could do that where the very first thing, it says there's a splash screen that says, welcome to my game. And if you really get fancy, you can get like preloaders that have, like the little thinking, loading things, or show percentages and stuff like that. But it could just be like, here's my game. Screen will start when assets are loaded. And then that happens. So yeah, cool. So that's a very minimal sort of state. Great. Yeah. So we'll check in with that stuff on Wednesday. And again, looking forward to the goals of end of next week, so a week from Friday, to have your game that you get posted onto this Moodle forum under week 10. Post us a nice working link, as well as a description of your like what your goals were, your design ideas, challenges that you ran into, hopes and dreams for the game for the future, etc. And then comment on each other's. Share the love.
I had a question on an issue that I ran into. If you guys have a minute,
Sure.
After all's said and done.
Yeah. So yeah, if you guys are good to go, you can take off. We'll have Wednesday. We'll also have next Monday. I think we'll plan. Maybe we can plan on meeting in sections. On Monday.
Yep.
Next week. So you'll have Wednesday to work on this with us. Monday and Wednesday next week. So you'll have some time, and we can also have some extra hours set up. Rad and Willow are on the scene. So good. So yeah, if you want to hang out, hang out. I have to go a little early today, actually. So, okay. But yeah, go for it, Christopher, and we'll.
And I just had a quick question as well, if there's a moment.
Totally.
Yeah. You first, because mine will probably take a minute.
Okay, all right. All I was wondering was, so I'm kind of taking on the ambitious thing of trying to make a platformer. Last Wednesday, I talked to Miles and Rad about that. And I was just kind of curious that as I'm doing this, like, of course, more and more challenges are being posed as I'm taking this on. But I was just kind of curious what point it should be at by the end. If there's things missing that I'm planning on adding, but if I have the mechanics working, that's, at this point, I have a lot of things done, but I'm just afraid of the possible challenges that might come up in the next couple of weeks.
Oh, good question. I always think about it like if you can kind of define a minimum viable product that would show kind of the concept of it. And so things might not be entirely 100% worked out. And that can be something that, it can be kind of a back and forth process to try to figure that out. I think there's an art to kind of taking things down and down and down and down until you get down to something really essential. I don't know. What do you think, David?
Yeah, I think that ideally it should be somehow, minimally playable. So thinking about what that means in terms of your, the sort of platformer idea. If it's like still had like if there's objects that you're able to, so there's a character, maybe there's targets or something like that you're able to collect, but maybe the functionality of like landing on each of the platforms isn't quite working yet. That's.
I'm just trying right now. I have all the assets loaded. Like I've made assets, they're in, and right now I'm trying to get the Gravity JS working, as well as like the ability to like put platforms. And I'm pretty like optimistic about where it's going. I was just kind of curious.
Yeah, I mean, that sounds promising to me. And it's like if things like Gravity don't happen yet, I think that certainly like wouldn't be like, oh, that's you didn't make the cut. No, I don't think so. I think it'd be totally fine. Like your character, you can like freely float up and down and move, like move around that way and that kind of stuff. So things like that are really kind of additions above and beyond what we've demonstrated. Even though you'd think that they would be like essential to that game as a, like if you launched the game, you'd want that to happen. But I think stuff like that you can think of as like, well, it's fine. We understand that that's coming.
Okay, cool. Last thing, don't have to take any more time, is that 1.5 assignment. There will be like a submit for that, right? That's the other thing that's due.
Yeah, let's see. So the 1.5 is currently, I think I might need to make that a little more explicit.
I wonder. Oh, sorry. I mean, I'm wondering too. As I was looking at it when Sean asked that question, I mean, maybe that just becomes the final.
Yeah.
Do we might not need to have a 1.5 because you're basically doing your final game. You know what I mean? And
I think so. Yeah. You can basically add sound and finish up all the other stuff is basically what it is. Yeah, and add those other, and then you can, because really the 1.5 demo in there is kind of more advanced than we're expecting people to get to with their individual things.
Got it. Okay.
We
So
can
mainly
clarify
just the final project that you're working on individually.
Yeah.
Okay.
We don't want to have another turn in, I think. I know I said something different, but I don't think we want to have another turn in at this point except for the final.
No worries. Thank you guys.
Yeah, cool.
Sure.
So David, are